So it's an empty house.
Good morning, good afternoon, good evening, whatever the case may be. We are back in better than ever, and today we are talking about three-dimensional problem solving. Do you like the trigonometry? Love the trigonometry. Let's get right to it, shall we? Let's have our little talks about three-dimensional problem solving. Here we go. Just one example. Ladies and gents, we got a cube here, has sides of length 10 centimeters. So all the sides are 10 centimeters because it's a cube. Find the angle between the diagonal AB. So let me go ahead and draw that. The diagonal AB, need to get a solid line here. So here, AB right there. Okay. And let's see, the diagonal AB of the cube and one of the edges at B. One of the edges at B. That's that's worded kind of, well, I guess it could be this edge or this edge or this edge, but they're all going to be the same because it's a cube. So I'm just going to make it easy and just go straight down, okay? And that is the angle that we're looking for right there that I am going to call theta, if you can picture it, okay? And so what do I know? I know that BC is 10, yes, and I know because of the cube here, and I also know that this is, BC is perpendicular to AC, so I'm going to draw a triangle ABC here real quick, and let's think about this for a minute. Let me go here. So I'm just going to draw it sideways, if you don't mind. So I'm going to recopy, and not recopy, but just kind of draw, and I'm just going to pull this out and just lay it flat on our screen here. Okay, so let me just label what I have. I'm going to say that this is A, and this is B, and this is C. And I've just laid it flat on our screen. And then I'm going to connect A and C, just to make life a little more interesting. Well, again, let's label what I know. First of all, I'm looking for this angle theta. I know that this is 10, and I know that this is a right angle. Okay. So if I were able to find the length of any other side of either AB or AC, I could use trigonometry to solve it. Now you might be saying, well, aren't these 10? Well, no, the edges are 10. This is 10, this is 10, this is 10. All these edges are 10. But AC is not 10, and neither is AB. So what are we going to do? Well, we have to be able to look at things a little bit differently. We have to be able to imagine some things. Let's think about AC. I don't know what AC is, but I know all the sides around AC are 10. So let me just draw that flat on the screen. I'm going to draw the bottom of the cube on the screen. And since it's a cube, I know it's a square. So I'm just going to draw as well as I can a square here. And forgive me if it's not to scale. Okay, so we're thinking a little bit here. Thinking just a little bit. And I'm going to say that this corner corresponds to A, and this corner corresponds to C. Do you know what I've done? See what I've done here? So this square is just the bottom of this cube. And I know that all of these sides are 10. Okay? And what I'm looking for is the length of the side AC, right here. Right here. Okay, and I'm going to call it X. And if it's X here, it's also X here. It's the same length. Okay? Well, boys and girls, we got ourselves a square, don't we? And if we have a square, this is a right angle. And if I just look here, don't I have a right triangle? And don't I know that I have two legs of a right triangle? So I can use my good friend Pythagoras that says a squared plus b squared is equal to c squared. And the important part is c is the hypotenuse, and a and b are the legs. So that means that 10 squared plus 10 squared is equal to x squared. 100 plus 100 is equal to x squared. 200 is equal to x squared. Okay? Then I'm just going to take the square root of both sides to get rid of the x squared, because the square root of x squared is x. And I'm just going to leave this as the square root of 200, because that is an exact answer. And it's not my final answer, remember? I'm trying to look for this angle theta right here. So now I know that x is equal to the square root of 200, because x represents the length of AC. AC, AC. Well, now I'm in business, because I have two sides of a right triangle and I'm looking for an angle. And so I just look at the relationship. Root 200 is opposite the angle. I guess I should write this down here. Opposite. While 10 right here is adjacent. It's next to it, and it's not the hypotenuse. The hypotenuse is over here, which is always opposite the right angle. So I'm going to use opposite and adjacent. That's the tangent. That is the tangent trig function. So I know that the tan theta is equal to opposite root 200 over adjacent 10. So therefore, to solve for the angle, theta is going to be the arctangent of root 200 over 10. And then it's just calculator time. Remember, you can also think of this as the inverse tan. It's the same thing. It just, some calculators do arctan, some say do tan -1, whatever. Our online calculator, Desmos, is arctan. So I'm going to go there, and I'm going to go to functions. I need arctan, and I need my square root symbol. I hope this is it. I haven't used it yet. Yep, good. Square root of 200. Now you have to be careful, because you need to space out. Right now you're under the square root. So before you put the division symbol, you need to go outside the square root, then put over divided by 10. Okay, and again, this looks a little odd, but remember, if you have not been using Desmos and you haven't changed it already, you need to switch 2 degrees. And we got an acceptable answer. Rounded to the nearest tenth, we're going to have 54.7 degrees. All right, come on. There we go. So theta is approximately equal to 54.7 degrees. So we just need to be a little bit careful. We need to look at things a little differently, and then this problem doesn't become so bad. All right, that's all I have. Let's see what of Monsters and Men, if they're still having their little talks. I think they are. Body safe to shore. I am out. Hope you enjoyed it.